Well, that's great and all when I know how to do my antiderivative, right? I can do my antiderivative of 2 divided by x minus 1, but I'm not guaranteed to get something nice on that denominator. So oftentimes, after the long division step, I will need another step. What I'm doing is I'm going to factor my denominator as far as possible. So in technical language, I would say we are factoring it into its irreducible factors, those terms that cannot be broken down any further. So how do I know when I've got one of these irreducible factors? Well, off the bat, I'll tell you that any linear term, just ax plus b, is automatically irreducible. So if you get down to linear terms, that's completely factored. You could have higher degree factors, but the very nice thing about working in the real numbers is that we only need to worry about irreducible quadratic terms. So if you have a cubic, if you have a quartic is degree 4, if you have a quintic is degree 5, if you have a sextic is degree 6, if you have a septic is degree 7. Okay, no, none of that vocabulary is going to be tested on this class. We only need degree 1 and degree 2. If you have anything higher than that, they're going to be reducing to at least linear or quadratic terms. So if you have degree 3, you're not done factoring. If you have degree 4, you're not done factoring, and so on. So for example, here is a nice polynomial. Q of x is x to the power 4 minus 6t. Fine looking quartic formula, quartic polynomial for those playing along at home. I can first factor it because I'll say that I've got my difference of squares formula. This is a nice little algebra trick that I like to use whenever possible. I'll say that this is really x squared to the power 2 minus 4 to the power 2. So I can easily undo that and say I've got x squared minus 4 times x squared plus 4, right? If I FOIL these back together, I get what I started with. Now, the x squared plus 4 is irreducible. How do I know that? It has no roots. The very smallest it can be is when x equals 0, and I'll get a value of 4. All other x values give me larger x squared plus 4 values, so no roots. That's irreducible. Cool. That x squared minus 4, however, that does reduce. And again, I'm going to use my same difference of squares technique. So I've got an x squared, and I'm subtracting a 4. That factors as x minus 2 times x plus 2, 2 being the square root of 4. Yeah, cool. So factoring, it's still important.